Welcome to Smart Notebook Math Tools. In this session, we will be showing you how to do some dynamic graphing, linking, and integrating some of Math Tools applications. We'll also show you how to connect to the Texas Instrument Graphing Calculator through the emulator icon. First, we'll start with adding shapes to the graph using the Snap to grid. We'll then display the coordinates of the vertices of the shape and display its side length. Finally, we will reflect the shape. Here's the example. Construct a square at the following points. First, select the shapes icon and the icon for a square. Draw the square onto the grid. Then, selecting the square, use the pull-down menu to show the vertices. Selecting a vertex point, drag the point to one of the points that you want to graph, and do the same for each of the vertices. Notice the crosshairs show up as a vertical and a horizontal red line as you approach the snap to point. Verify that you do have the points for the square by first of all selecting the square using the pull down menu and then showing and hiding or show the vertex points. There you can see the coordinates of the points indicated. Next, just to check again, we can show the side lengths to see that each of the side lengths are 3 units in length. Once we verify that we have the square at those points, we can then reflect the square using the pull down menu. So select reflect shape and reflect over the line x equals 0 for the y-axis. We could also reflect the image square. So first select the image square, use the pull down menu, select reflect shape, and this time let's reflect that over the line y equals x. To continue with our dynamic graphing, we'll now generate graphs, tables, and equations. First, generating graphs from tables. Highlight the table, use the pull-down menu, select Math Actions, and generate graph. These are dynamically linked, so I can produce additional points on the graph by double-clicking for a point. And as we do that, you see the point appear in the table. So we can interpolate points or extrapolate points by adding points to the graph and seeing that appear in the table. You can also remove points by double-clicking, and the point is removed from the table as well. As we highlight the table, you'll see that dynamic link, and we can break that link by selecting the X between the blue squares. Now that the link is deselected, we can next change points in our table, and that will not be upgraded in the graph. So as I open the keyboard and select 3 and change that to 3.5 in the table, and then the Y value, changing that to 7, closing our keyboard, and then you see the changes in the table, but not on the graph. Now, if I reestablish the link, and you see a blue box to the left of the highlighted table, if I drag that blue box to the graph, it reconnects the link, and now you see the graph has been upgraded to the points on the table. Here's an example where this will be useful. Here we have two tables and a problem about the running times for men's and women's races. So we've seen this problem before. Highlighting the table, we can now generate a graph using selecting math actions and generate graph. Doing the same with the women's times, we will this time use the blue box on the left of the table, drag it to connect to the grid so that the points appear on the same grid. Students can now enter into discussion. We could use lines of best fits. So constructing a line through the points, we can show the trend for the women's times as decreasing. We can also show the trend for the men's times as also decreasing, but at a slower rate. And so then the students can have that discussion about, will the women outrun the men at a future time? We could also generate tables from graphs. This time selecting the graph, using the pull-down menu, selecting math actions, we can generate a table. You can see the dynamic link between a table, and the same applies if we put points in our graph, the table will be updated. And we can also break that link so that if we remove points, or if we remove points, you will see that nothing has happened to the table. And as we reestablish that link, then that graph is once more updated to the table. Here's an example. What relationships exist between a table of values and a graph? So here's a graph. Selecting it, using a pull-down menu, selecting math actions, and generating a table, and now have the points that appear on a graph. Now, as we start to explore relationships in the table and relationships in the graph, we can make some comparisons. So looking at the table, we could calculate our finite differences. So as x changes by 1, we see that y has a difference of 2. Then exploring on the relationships on our graph, we could use some of our other tools, for example, our irregular polygons, create a triangle. And as we select this triangle, using the pull-down menu, we can show our vertices. Selecting a vertex, we can drag it to snap to a point on the line. And we can also create a right triangle using the crosshairs in red. And then we can select to show our coordinates. So showing the vertex points. And then using that to calculate our rise and our run. And then looking at that rise to run to calculate our slope, and seeing the relationship between our slope and our finite differences from our table. The third part of dynamic graphing is to generate graphs from equations. So here we have a written equation, and we can highlight that just by clicking on it and recognize the math ink and accepting that as our equation. And then using the pull down menu, selecting math actions and generating a graph. Note that the y-intercept on the graph is at 3. Now, as we edit our equation, we can open up our keyboard, select our, double click on our equation for the equation editor, and change our constant from 3 to 0. And then seeing how that affects our graph. So now we see that the y-intercept is at 0. Notice the dynamic link between the equation and the graph. Probably be better to see in an example. We can see both equations on the same axis. So in the case of y equals x squared, if I again select both of this portion and recognize the math ink, I have the equation y equals x squared. If I now use the pull down menu and select math actions and generate a graph, the graph of y equals x squared. Highlighting the other equation and using pull down menu to recognize the math, we have the equation y equals x squared plus 3. And as you notice, the blue box on the left of the equation, if I drag that to the graph, I can link that equation to the same grid and see the new graph appear with the original graph. To see this translation better, I may want to change the properties of the graph. So highlighting the graph, selecting properties and graph settings, and opening up my keyboard, I can start my x-axis at -4, end at +4, and have a step of 1. And then I can start my y-axis at 0, end at 20, and have a step of 5 units. And as I click off, I can now better see that translation of y equals x squared to y equals x squared plus 3. Now in the dynamic graphing and linking and integrating these applications, we can put all of these into one question. So here we have Liz's job offers a one-time bonus of $30 and a pay rate of $10 per hour. Model this relationship using a table of values, a graph, and an equation. So trying to integrate all these 3 features. First of all, we would select the icon to produce a table. The students would then use the keyboard to input values that they calculate. So at 0 time, Liz would get their per bonus of $30. Then after 1 hour, Liz would be paid $40. After 2 hours, she would be paid $50. And let's say after 5 hours, she would receive $80. Now by highlighting the table and selecting with our pull down menu math actions, we can generate the graph. So now you see the points appear on the graph. The students could then calculate using the table or graph an equation for a line that goes through those points. So in this case, they could figure out that y would equals a rate of $10 per hour plus her $30 bonus. Now we see if we can recognize that with our Math Inc. And no, didn't recognize it, so I'm gonna try that one again. Let's rewrite that. Y equals 10x plus 30. Hopefully this will now be picked up as an equation. That's better. So we have y equals 10x plus 30. Notice the blue box on the left of the equation. If I now drag that to the graph and link it, we now have the line appear on the graph going through the points. To check that that is the line through the points, we can press our icon in the hidden menu on the bottom of the graph. And as I press that icon, it should overlay that line. Okay, so the students can check back and forth between the links between the equation, the graph, and the table. So as I highlight all three, we'll be able to see the links between all three components. Okay, the last step is to see our last icon on our secondary toolbar before the selection arrow is the TI emulator icon. And so with this, if you have TI Inspire SmartView or SmartView as a licensed product on your computer, you will be able to launch it with this icon. So as I click on the icon, I have a TI SmartView TI-84 on this computer. It may take a while to boot up. So we'll just wait for that as it opens. And then once I have it open, I'll be able to use it as a regular graphing calculator on my smartboard. And as I produce graphs and lists, I'll be able to drag and drop screenshots right onto my notebook page. So here we have the graphing calculator opened up, the emulator. And you can see we can go back and forth between different functions. So here we have a table. I can drag that table right from my screen onto my notebook page. I can ask for a graph of that. And I can again drag it from the screen right onto my notebook page. Or I can grab any one of the windows on the right and also drag it to the notebook page. As I close my graphing calculator emulator, I can now use these pieces in my notebook page anywhere I like to produce my lesson. A very great feature to have that integration between the TI emulator software and the notebook software. So this summarizes many of the applications that we've seen using Smart Notebook math tools.